I am the worldwide infrastructure architect for DST, which means that I'm in charge of making sure that we have what we need to serve our customers around the world. DST is a pretty big organization now. We started out much smaller, but we've got about 4,000 servers worldwide now. Development and test. Our mission is development and test, and we kind of follow the lean type philosophy of we want to do what's necessary to meet IBM security requirements and to serve our customers, and not a bit more. We provide just the infrastructure for people. We call it, of course the new term is infrastructure as a service, but we've been doing it for years. And so in order to provide the infrastructure, we've got the hardware and the operating system support and the security support. Someone can just come in and just say, I need a machine that's yay big, and we say, here you go. We have it already, sort of ready on demand, is the old term we used. Again, now it's infrastructure as a service. They don't really have to worry about all the details. They just say, I need something yay big. And then on top of that, we offer platform support for various platforms that IBM tends to use a lot. We've got Webster Application Server, of course, the J2EE type of apps. We've got DB2, for database type apps. We have the IBM InfoSphere Information Server platforms, Lotus Domino, all these different development platforms that IBM uses, we provide platform support for. So the developers don't have to know how to install this, how to configure this, how to create this connection between this and that. All that stuff that's not project specific, that's really specific to the underlying platform, we can take care of. The cloud is an interesting story. We were approached by the CIO's office in conjunction with IBM Research and Software Group to create a private dev test cloud inside of IBM. And they came to us because we do dev test, and we do it well. So my first reaction actually was, it's just not ready yet. Let's wait around. Let's let somebody else walk through the minefield. It's just not quite ready yet. And the technology wasn't quite ready when we started this over a year ago, but it's come up to speed quickly, and I'm proud to say now that we have not only a private dev test cloud for the IBM Global Account. It's primarily for the folks on the IBM Global Account, but anybody in IBM can use it. Not only do we have that running, we are actually the reference implementation for when we want to sell private dev test clouds, or private clouds at all really, to other companies. This is how we do it. We do it the same way as what we implemented here. A private cloud is internal to an organization, or hosted, specifically for an particular organization, and nobody else gets to use it. And even so, it's very useful, especially for large organizations. Before, you might have had Department A, Department B, Department C. All of them go in and get their own capital expenditures, and they buy their own equipment and everything else. And so you set up a single cloud in the middle, so to speak, and everyone can come in as they need to and use it. Now, Department A planned for their peak capacity. They need 100 servers. Department B planned for their peak capacity. They need 100 servers. And Department C planned for their peak capacity. They need 100 servers. But if you actually look at it, chances are very rare you're ever going to need 300 servers, because their peaks don't line up at the same time. So you can buy 150 servers and put it right here in the middle in a cloud. Doesn't even really have to be a cloud, but cloud is the self-service way to do it. It avoids all that extra process that comes from centralizing. And when somebody from Department A wants a server, they can just go in and click and say, I want a server and I want it to be A big. In 30 minutes, it's automatically approved and given to them. It's just as good as if they had run it internally. Better, in fact, because instead of Department A having to have some people trying to run servers and Department B having to have some people, you can centralize that and have one group running servers. You get some economies of scale and the specialization, but you don't end up with all the extra process, which is why Departments A, B, and C tried to do it on their own to begin with, because they didn't want to have to deal with all the central process. If it takes a month to get a server, you're not going to let go of it. You're going to keep a hold of that server, whether you need it or not, because you might need it next week, and you don't want to wait 3 additional weeks and mess up your schedules waiting for it. If you know that I can just come in anytime I want and click this button and I'll have a server in 30 minutes, you're willing to let go of the things. You don't keep them running when they don't need to be running, because you get billed. Every hour you have that server running, you're getting billed for it, and so that's an incentive to not keep it running when you don't need it. So in that sense, the cloud is green. So one of the most interesting things we did about cloud was to change the business process around. Before, we used to have customers come to us and say, I'd like a server about yay big with this, this, and this on it. And we would go and give them a quote and get approval for the charges from them. And the whole process took around 5 days, which is very good. But it's still 5 days. And now, the main reason we couldn't go ahead and start work on it is because sometimes the funding wouldn't come through, and we would have spent 10 or 15 or 20 hours of setup time that we couldn't get paid for at that point. And with the cloud, there's no real setup charge. The system handles it automatically. So we sat down and thought about it and said, we really can go ahead and let people provision the stuff on the cloud, provision servers on the cloud, and if they can't pay for it, it's no big deal. We'll just turn it back off. It's not really costing us a lot of setup effort. So now, when someone comes and wants to get on the cloud, we'll say, okay, here you go. You have, you've got a 3-day grace period to go ahead and get us the accounting codes, but you can go ahead and start work immediately. And so that really helps cut the turnaround time from around 5 days from the end-to-end process. We've cut so much out of that process that they can get it in about 30 minutes or an hour. So DST's Lexington data center is hosted inside of a commercial data center. So in other parts of this, there's customer confidential. So we actually have to go through a man trap to get in here, which only allows one person in. Person trap only allows one person in at a time, and it'll set an alarm off if you try to tailgate. It also requires not only my badge but a fingerprint. It's biometric. And this is the data center. Now our cloud itself is run off of a virtual machine on one of these here. It's at 25,170. So let's find that. That's sort of the nature of cloud. I don't know exactly where it is. Here's the XY coordinates, 25,170. In our database, we have a list of all the servers that we maintain and XY coordinates for each of them. And so I looked up the server that's running the cloud system and found the XY coordinates. And so I just have to go to the XY coordinates and find the machine that's labeled the same. So the actual cloud itself is hosted on one of these Intel boxes right here. I think it's this one here. And so it's just a virtual machine on there. All of our infrastructure is virtualized. Some of these are managing the cloud, and then some of these are actually providing X-Series capacity for the cloud. So if you want a box running Linux or Windows, it'll be provisioned onto one of these here. The one that's behind you here, this is our mainframe. This isn't on the cloud at the moment, but this is one of our mainframes, and System Z9. And so we run, I think this has 80 or 90 Linux guests all on it. This is actually a fairly small mainframe as they come. The other one we've stood up is bigger. Over here are some of the storage units that we have. This is our storage, one of our storage area networks here. I like this because of all the blinking lights. But these are showing I/O requests coming in from the individual machines that go to these storage units over here, which are basically boxes just packed full of disks. We've got some older ones here, pretty much everywhere. A geek? Well, probably about age 5. Honestly, my mother took me in, she worked in computers, and took me in to work occasionally, and to keep me busy, she sat me in an old DEC VT100 terminal and turned on the local echo so that it was just repeating what I typed, and I must have messed with that for what felt like days, although it was probably 5 minutes. And when I got bored with that, with typing the letters and seeing them appear on the screen, and I figured out very quickly, of course, that you had to hit return and line feed to go down to the next line, and typed up little things. And so she got me an account on the VAX there that only had access to the games, and so I got to learn a little bit of VMS while learning how to. I ran the original Colossal Cave Adventure, which is one of the first text adventure games. Interestingly enough, Crowther and Woods, Crowther was caver here in Kentucky, and I didn't find all this out till later, but Colossal Cave is actually based on parts of Mammoth Cave here in Kentucky. So, and I think my first job was actually designing fonts for badge printing for Mom's business. That she needed to print badges, and none of the fonts they had were large enough. And so at the age of 12 or something, I took a font editor, and I'd actually done this on my Atari before, so I had experience, and blew those fonts up to be nice and usable for badges, because this was long before the days of vector fonts or of freely available fonts. I design systems made up of multiple computers and put them together in a manner to solve a business problem. And I also get to play with a lot of neat toys and do some really neat stuff like cloud computing. I really like my job. I really do.